Welcome and thank you for joining today's webinar. During the session, we'll be discussing common process and wastewater treatment challenges in food and beverage plants and how ZwitterCo membranes can overcome them, with a particular focus today on Europe. We're also very excited to highlight one of our European partners, Esmil, who will be joining us today to talk about some of their projects where they've incorporated ZwitterCo membranes in the region. We will be having a Q&A session at the end of the session, so please submit your questions via the Q&A functionality as we go along, and we'll try and answer as many as possible at the end. Also, the webinar is being recorded, and the recording will be shared with everybody a couple of days after. Now I'll pass the reins across to Brendan, who will introduce the speakers.
Thank you for that introduction, Rob. Today's webinar will be presented by myself. My name is Brendan Curran. I'm a sales engineer based in Madrid, Spain. Brett Thompson, he is a senior applications engineer based on the East Coast of the United States. And our special guest, Parag Kachare, someone who I've personally been working with for a few years. He is technical director of Esmil Process Systems, and he is based in the United Kingdom. In today's webinar, we're going to cover a variety of different topics. The first, we will start with market trends and market drivers in Europe, specifically within the food and beverage industry. Next, we will move on to the current treatment landscape and the common challenges that arise within these streams. After this, we will discuss ZwitterCo's unique membranes technologies and how it's helping to solve some of these challenges that we see within this treatment space. Next, we will hear from Esmil. They will talk about their capabilities. They will highlight some of their experience using our membranes, as well as two of their case studies in the United Kingdom. And then finally, we will cover our membrane products and how you can easily integrate them into your existing treatment processes. So to get started, I will hand it over to Brett, and he will discuss some of the key characteristics of the food and beverage wastewater that make it so challenging to treat.
Alrighty, thank you, Brendan. So first, we're going to go ahead and set the stage on with some context of what makes process and wastewater from food and beverage plants so unique and challenging. So some of the key characteristics, you typically have high levels of organic matter. It could be in the form of sugars, proteins, fat, oil, and grease, or fog, and then carbohydrates of varying complexities. You can also have inorganic compounds, so you can have nutrients, nitrogen, phosphorus, and then other inorganic compounds that can cause discharge or material construction considerations. And then on the wastewater side, you need to have a wastewater treatment system that's capable of handling these rich, diverse organic loads. The high levels of fog typically require pre-treatment to avoid any downstream complications. You have TSS, or suspended solids, that needs to be handled. And then typically in food and beverage plants, you also have CIP, or cleaning water, process water, which can have a wide variability in pH and temperature that can then impact any sort of biological processes you might have, or anaerobic, aerobic. There can also be variability in just the plant itself and what they're producing over the course of a day. There's different shifts. There's different products that are being produced. And then even over the course of a year, you could have different products that a plant's producing. So you need to have a wastewater treatment plant that can handle all of these variabilities. And so there are risks associated with having inadequate treatment. These are environmental, financial, and operational. And so I'll go ahead and turn it back over to Brendan to talk about some of these.
Thank you, Brett. After talking about some of the treatment challenges that he was just mentioning, we're going to cover the reasons why there's a need to focus on the wastewater treatment of these plants. As this slide is showing, there are a number of different drivers shaping the wastewater strategies within food and beverage companies. First and foremost is compliance. Regulations around wastewater discharge are getting tighter, whether this is nutrient limits, contaminants of emerging concern, or needing to hit mandatory reuse targets. All are needing innovative treatment technologies to help treat these wastewater streams. The second on this list is costs. Surcharges for discharge, hauling costs, and disposal fees can be significant at food and beverage plants. The right treatment process is going to drastically cut down on operational expenses to avoid these reoccurring charges. Third is water reuse. This is becoming a major strategic sustainability goal for food and beverage companies that are trying to reduce their water usage rates. This is especially true in places that have to do water reuse because they're simply lacking available water and they're in water-stressed regions. Fourth on this list is production continuity. Any disruption caused by treatment issues like too much fats, oils, and greases, variable flows, or changes in feeds can significantly interrupt operations. And finally, a lot of companies are looking to future-proof their wastewater treatment plants, looking ahead towards the next wave of regulations with nutrients and contaminants of emerging concern. Looking around the corner is enabling these companies to anticipate and be prepared for what is coming next. Overall, it's not surprising that food and beverage companies are rethinking their wastewater strategies. So now Brett is going to take a closer look at the current treatment technologies that are being used and some of the gaps that are present within these wastewater treatment processes.
All right, thanks, Brendan. Yeah, so some of the most commonly seen wastewater treatment processes in food and beverage plants. Number one would be biological systems. So these are processes where you're using microorganisms to consume biodegradable material, which is typically measured by BOD or COD. And you can also remove suspended solids with these processes if you have a clarifier or an MBR to go along with the reactor. They can also remove nitrogen and phosphorus, some other nutrients from the water, depending on the organisms that you have. So some examples of these, activated sludge is kind of the conventional thing you think of when you think of biological. These would be a continuous flow through reactor, usually a pretty big footprint. And then these other ones listed here, sequencing batch reactor, MBBR, membrane bioreactor. These are all ways to kind of consolidate the footprint and in the process to have a smaller process overall. Dissolved air flotation or DAFs are also very common in food and beverage plants. These are, it's a physical process where you're trying to remove fog and suspended solids, typically by adding coagulants like ferric or alum, and then polymers as a flocculant in order to try to group all of the suspended solids together so that they sink and are removed as sludge. And then you would add air into the tank to try to get the lighter organics like fog to float to the top. So both of these are very mature processes, but they also have some drawbacks. So biological treatment will pass non-biodegradable material. We call that recalcitrant organics, which can lead to issues meeting COD effluent limits. Biological processes are also sensitive to variations in feed water quality. So if you have different nutrients coming in, different levels of organics, temperature, pH that we mentioned earlier from some of the CIP processes, cleaning chemicals, you can actually stress the microorganisms, and that can result in issues meeting discharge limits. In a worst case scenario, you could actually kill off your microorganisms, and then you would have to spend time, days or weeks in order to rebuild their population. And during that time, you could suffer from fines, surcharges, or even in worst case, pulp production. DAFs are not as prone to catastrophic events as biological treatment systems are. But the issue is that they pass dissolved components. So these make up typically a large portion of your COD and BOD. They're not a positive barrier like membranes, which we'll talk a little bit more about later. So you can also see breakthrough of fog, of TSS. And so typically to handle this, operators will overdose their chemicals or coagulant, flocculant, which ends up costing more money. And you see diminishing returns where you're adding more chemicals, but you're not necessarily getting better results. And so while I mentioned membrane filtration is a positive barrier to all of the things that are mentioned on this page, conventional membranes typically suffer from fouling or plugging when exposed to high levels of organics and fog. And so this is where ZwitterCo comes into play. So because irreversible organic fouling is such a challenge, researchers and companies have been trying to develop new material chemistries to deliver a meaningful step change, leap forward in membrane performance and to address fouling. So one of these new chemistries has been developed by ZwitterCo and uses zwitterions. So zwitterions are small organic molecules that have an equal number of positive and negative charges for an overall net neutral charge, and they are extremely hydrophilic or water-loving. So they're so water-loving, they actually create a hydration shell, and that prevents interaction with organic foulants. So they're essentially an innate anti-fouling molecule. So researchers have been trying to incorporate these into membrane chemistries for over 2 decades, but they're very difficult to handle. So the real breakthrough was incorporating zwitterions into a copolymer, an organic copolymer backbone, which provides structure. And then these zwitterionic copolymers are able to self-assemble into a zwitterionic membrane. And so this allows for an actual active layer similar to a polyamide, for example, on an RO membrane that's able to recover upon cleaning, even after being exposed to very high strength, high organic fouling wastewater, especially the wastewater that you'll see in the food and beverage industry. So let's go ahead and go to the next slide. We'll take a look at a membrane in action. So this is just a quick time-lapse video of a superfiltration membrane, which Brendan will talk a little bit more about on the next slide, that's been fouled with an organic foulant. And in this video, it's just being flushed with water, just clean water, no chemicals. And in this case, this is just a demonstration to show how organic foulants don't stick to the membrane surface and can be easily removed. So I will go ahead and turn it back over to Brendan to talk a little bit about some of the technologies that we discussed.
Thanks, Brett. And as he was mentioning, the ZwitterCo copolymer chemistry is a technology platform that we've expanded across multiple different membrane products. So I'm just going to quickly discuss the 2 commercialized products that we have available today. The first is superfiltration, which is what you saw in the video prior to this slide. This was the first product that was commercialized, and some of the key characteristics is that it is a 1 kilodalton molecular weight cutoff, so it's classified as a tight ultrafiltration membrane, meaning that it's still going to allow salt passage. There's 3 use cases for this superfiltration membrane product: treatment of wastewater for discharge, pre-treatment prior to RO, typically in streams like the above use case. And we've also used it within process, specialty, and food streams for concentrating specific components within that stream. Like all of our products, it is used in high fouling feed waters. And this product specifically is fully compatible with chlorine, and it is exceptionally well at handling oil and grease. The second product lines that we were commercialized is the brackish water RO products. So we have 3 different brackish water RO products available: a low energy, a high rejection, and a high pressure brackish water RO product. These are intended to be direct drop-in replacements for other RO membrane products on the market. It is a polyamide membrane with bonded zwitterionic protective layer, and it is used in RO installations that have elevated organics going into the RO system, and it has also been performing well even in streams that have small amounts of oil and grease going into the RO system. Like other RO membranes, this product cannot be chlorinated. Next slide, please. So as a result of the zwitterionic copolymer chemistry, we have built some of the world's most fouling resistant membrane products, specifically with organics. You are able to reduce chemical costs using these membranes. In a lot of our installations, we've been able to switch from expensive formulated chemicals to commodity cleaning chemicals. And we've also reduced the amount of chemicals clean-in-place cycles needed. You are going to have faster cleaning cycles using these membrane products. If you're able to simplify or shorten in the cleaning steps, you're going to have faster cleaning cycles. You will have more system uptime. So our membranes, when they can run for longer between a cleaning cycle needed, and if they're able to achieve full performance recovery, which we've seen in a lot of our current installations, you're going to have less production downtime. We are enabling more reliable, easier, and safer operations, even when systems have higher level of organics. When you have less system maintenance needed and you're using commodity cleaning chemicals that are easier and safer to handle, it's encouraging this. And then lastly, our membrane products offer the industry's highest guidelines for organics and oil and grease limits. They're a one-for-one substitution with a lot of other industry membrane products and allow for easy implementation at a lot of facilities. So at a high level, by incorporating ZwitterCo membranes into your plant, you can not only treat your high-strength wastewater streams that other conventional membranes struggle with, you can also effectively generate clean water for reuse at these sites. So how do ZwitterCo membranes solve the common pain points that we were discussing earlier? Brett, I'm going to hand it over to Brett again, and he's going to explain how we're fitting into different treatment processes with our membrane.
All righty, thanks. Yeah, so as you'll remember, I mentioned biological treatment is really good at removing readily biodegradable organics, but it will pass recalcitrant or non-biodegradable organics, which can be a problem for downstream processes. So one solution is to use ZwitterCo RO after biological treatment systems. Using RO after biological treatment is not a new concept, but RO membranes after biological systems typically are very prone to fouling, especially if you have any breakthrough of organics or anything that can get to the RO membrane. On a conventional membrane, you can see fouling issues. So using ZwitterCo RO means that you don't have to worry about this, and you can still produce a high quality permeate and meet whatever discharge limits you have, or potentially even enable reuse if that's available in your facility. DAFs, on the other hand, the most common pain points are typically the high cost of coagulant and flocculant, and then also frequent passage of fog and TSS. So using ZwitterCo superfiltration after a DAF will completely reject any remaining fog, any remaining TSS, and it actually lets you, we've seen in a lot of instances where you can operate your DAF either at a reduced chemical consumption or by completely eliminating your chemicals and operating it in an air-only mode, which will just remove the bulk suspended solids and fog. And then the superfiltration membrane can handle extremely high levels of fog and other organics, COD. So it'll be able to handle whatever gets through your DAF. So running it in this way, you can dramatically reduce your OpEx and produce a higher quality effluent. All right, so I'm going to go ahead and turn it over to Parag Kachare, who is with Esmil Group, and is going to talk a little bit about Esmil's experience with ZwitterCo's membranes.
Thank you, Brett. Good afternoon, good morning, good evening, everyone. My name is Parag Kachare. I'm the technical director at Esmil Process System. Esmil has been based in High Wycombe, UK for over 40 years. We specialize in providing solutions for the industrial water and wastewater treatment with extensive expertise in the wide range of membrane technologies and their application. Esmil has developed and supplied a treatment solution for various challenging wastewater streams, that including produced water from the offshore oil and gas, MDF factory wastewater, acidic wastewater from the petrochemical industry, digestate from the anaerobic digestion plant, and effluent from the food and beverage industry. And it is very important to highlight that all these process technologies has been developed through the comprehensive piloting, starting from the trials in the Esmil lab to prove the process, followed by the long-term test work at the site using the real-time feed and the industrial modules. This approach allows us to gather detailed data, which is essential for the accurate plant design. And that also gives confidence to the customer the process can work. Yeah, next slide, please. Some pictures coming from the site test work. So we got a the complete setup when we go to the site, the membranes, different type of membranes, the membrane kits for trying a pre-treatment using whether it's ultrafiltration, nanofiltration, followed by the reverse osmosis. And we go to the site, as I mentioned earlier, to collect the comprehensive data for the test work. Yeah, this is the setup for one of the customer where we tried the produced water to achieve very stringent discharge consent. It was in Netherlands. Okay. Currently, Esmil is collaborating with ZwitterCo on multiple applications. Today, I will briefly present two case studies where original membranes were replaced with ZwitterCo RO membranes, resulting in the significant benefits for our customer. This particular case study is for the effluent from food and beverage industry. Originally, the water was used to be tankered off-site to nearby anaerobic digestion plant. With the Esmil plant, fraction of the feed volume goes to the AD plant, which reduces the transportation cost significantly. Okay, next slide, please. Prior to this project, there were few technologies offered to the customer, and the technology comparison was carried out. The Esmil process tick all the boxes with respect to the feasibility analysis as compared to the biological and evaporational process. Evaporation process, as we all know, is a energy and expensive process, whereas the biological treatment is very sensitive to the variable feed and large footprint requirements. Yeah, next slide, please. This slide shows what was the design characteristic of the feed and what we actually seen when we started the commissioning. The COD was high in the first place itself, so we had to do long-term comprehensive trial. But when we started the commissioning, the COD was found almost 3 times higher than that. Because of that, we countered issues using our original membrane, non-zwitterionic RO membranes. It was struggling to keep up with the design values in terms of the recovery and the cleaning frequency. So Esmil decided to replace the membranes, the standard membranes, with the ZwitterCo RO membranes. Some of the pictures from the site during the installation stage. Okay, as I mentioned earlier, the membranes were replaced, and we had the team from ZwitterCo. He helped us troubleshooting the conventional membranes. So you can see we did a on-site autopsy of the membrane. We noticed a lot of solids, some issues with the membrane material and all, and we immediately decided to go with the ZwitterCo RO membrane. So as this project is it's a non-standard project, very high COD in the field, so there were some challenges. So I have compared here what we achieved using from the original design and what we achieved after replacing with the ZwitterCo membranes. So high organics restricted the recovery to 65%, whereas after the membranes were replaced with ZwitterCo RO membranes, we managed to go up to 75% design recovery, which was originally intended value. The cleaning frequency that has gone down, and the cleaning was used to be carried out with the surfactant-based cleaning chemicals, whereas with the ZwitterCo membranes, we just flushing with the hot water. It's a fortnightly flushing, so a lot of savings on the cleaning chemicals. The operating pressure, it is to be in the range of 20 to 25 bar. With the ZwitterCo membrane, we managed to reduce it to 25%, around 16 bar. And the cleaning was carried out at 50 degrees Celsius hot water with the ZwitterCo membranes. It used to be 35 to 40 degrees Celsius. Again, in terms of the support, we had very good support from the ZwitterCo team. As and when we required any support, whether it's any spares or any technical guidance, we used to get that. In terms of membrane availability, the original membrane supplier, they would take 3 to 4 weeks, whereas the ZwitterCo membranes has been always in stock. So that has been very helpful. So I'll go next case study where XMBR water is treated with the RO system. Esmil here supplied a system to treat XMBR water to make the water suitable for cooling tower makeup and to blend with the boiler feed RO system. However, upstream UF system was not always performing as designed, leaving a lot of organic slipping onto the membranes, RO membranes, causing organic fouling and frequent cleaning requirements. After consultation with ZwitterCo, Esmil replaced the membranes using the ZwitterCo RO membranes, of course, which greatly benefited the customer. So this application, the aim was to reduce the COD, run the RO plant continuously and reduce the TDS so that it can be used as a cooling tower makeup water. And we managed to achieve that on consistent basis using a ZwitterCo membrane. To summarize the benefits of ZwitterCo membrane, again, we achieved the same or similar result as the case study one. Higher recovery, cleaning is carried out only with the hot water instead of surfactant-based cleaning chemicals, operating pressure, some reduction in the operating pressure. Again, a lot of saving on the cleaning temperature, heating requirements, and customer services support's always been fantastic. Yeah, thank you very much. And I would like to take this opportunity to thank ZwitterCo for their support in this project and look forward to work on a lot more projects in future.
Thank you so much, Parag, for sharing your experience on Esmil and your experience working with us and sharing some of the benefits you've seen using our RO membranes at your 2 sites in the UK. A lot of you on this call are also outside of the food and beverage industry, and the first portion of this webinar was focused pretty much solely on that. So we wanted to take an opportunity to quickly highlight 2 of our other case studies outside of the food and beverage industry. And then we will continue on to a summary and the Q&A. So the first case study we'll highlight is a US power plant that was using surface water for boiler feed makeup. This power plant was experiencing a lot of biological growth and seasonal spikes in this, especially in the spring and the summer, where they were using conventional RO membranes at their site before. So using the conventional RO membranes, they were having to do aggressive monthly cleanings, especially when they were experiencing more biological growth, and they were replacing their membranes every 12 to 18 months. In addition, the plant was looking to emergency water management that could have been extremely expensive if these issues were not mitigated. So this was an installation that was put in with our membranes over 18 months ago. It was one of our first RO installations. And we were able to have a comparative data with it because they had multiple trains of RO on site. So in the first year, we were able to recognize a 70% reduction in cleaning frequency. The conventional RO membranes that were on site were cleaned 7 times, where we were cleaned twice. This really showed when we demonstrated our ability to handle the upstream upsets, because the conventional RO membranes were on site were experiencing a lot of issues when that was happening. And in addition, we were consistently having higher permeate flow, and we were able to extend the membrane lifetime of the conventional membranes that were on site. So the next case study that we'll quickly highlight is in the landfill leachate space, and I'll hand it over to Brett so he can talk about that.
Alrighty, thanks, Brendan. Yeah, so anyone, I know we have a diverse audience here. If you're not aware, landfill leachate is a very complex waste stream that's generated from the water that trickles down through solid waste landfills. We actually recently held a webinar focused solely on landfill leachate, which you can find on our YouTube channel. And it also talks about several different case studies and a partnership with Serpol, who also talked a little bit about some of their work in landfill leachate. But for this particular case study, this was a landfill leachate solution provider that provides mobile filtration systems to help struggling landfills meet discharge limits with RO membranes. And so prior to ZwitterCo, they were using a conventional RO membrane. They were cleaning every other day. And so because of that, because of the frequent cleaning, which can actually degrade an RO membrane surface over time and cause increased salt passage, they only had a 1 to 2 year membrane life. And then of course there's frequent downtime and maintenance associated with the cleanings. So they replaced with ZwitterCo's membranes. They went from cleaning once every 2 days to cleaning once every 10 days. So that resulted in a 80% reduction in cleaning costs and an expected 2x plus lifetime due to the less frequent cleanings. And so because this is a mobile solution provider, they actually saw increased revenue because they're spending less on cleaning. All right, next slide. Okay, turn it back over to Brendan to talk about the products.
So yeah, after all the case studies we've talked about, these are the products that we have commercialized, and these are the products that we use in a lot of these industries. So we have the super filtration product. It's available in the 46 mil spacer, and then we have our 3 different RO products. So with the high pressure RO product, we have 2 different spacer sizes, as they're often used in the landfill leachate space, for example. And then we have the high rejection and the low energy RO product in the conventional 34 mil spacer size. The RO is intended to be the direct drop-in replacement for the existing RO systems. In SF, we can work with you on a case-by-case basis to ensure that the systems that we're going to use superfiltration in are designed correctly with you. You can go to the next slide. So to wrap up what we've presented today, we've covered a lot of material and wanted to summarize a few items. The most important thing is that to know about ZwitterCo membranes is that they're truly unique in their ability to deal with wastewaters that have a lot of fats, oils, and greases and other organic foulants that conventional membranes often struggle with. We are helping promote sustainability within the food and beverage industry and other industries, and we would love to work with you to understand if our membrane products can be the right solution for your wastewater treatment processes. So thank you all for attending this webinar. I know some of you have already put some questions in the Q&A chat function. We would love to field some more of those questions. So if you have any questions now, or if you had questions earlier, we're going to start answering those.
Thank you, Brendan. I can see we've had quite a few questions in whilst we've been talking, so let's get started. So first question we've got here is ZwitterCo just making membranes or systems? Are you marketing to integrators or end users?
Yeah, I can answer that. So both. We're actually going to have a webinar this summer that talks about our solution capabilities. But yeah, we're able to do both. We can make systems for certain projects, and we work with integrators, we work with channel partners for their solutions as well.
Brilliant. Okay, and then the next one is, what is our high organic tolerance?
I will answer that one. So in terms of like specific organic limits, especially with the reverse osmosis products, we don't have a specific limit in mind right now, but what we're noticing is that in streams that are feeding higher organic loads into their RO systems, When we're put in, we are experiencing better operations than the existing RO systems on site.
Okay. Okay, next question. Would concentrate from the RO with ZwitterCo membranes not be at a higher TDS, TSS, BOD rendering if difficult to dispose of?
Yeah, I can take that. So yeah, any sort of membrane system, you're going to have a concentrate and a permeate that you need to be able to handle. The rejection, that the concentrate is going to be the same that you would see with a normal or a standard conventional brackish RO membrane. The big difference is the cleaning frequency, the organic resistance of the membrane. That's going to be the primary differentiator between our membranes and conventional membranes.
Brilliant. Okay, next question. Is there a cap on COD input to the ZwitterCo membrane?
Yeah, this is a question we get a lot. So, we typically recommend using our membranes, our RO membranes, where you would use another RO membrane that's struggling with organics. It's easiest it's a direct replacement. You can go ahead and replace a train or a stage that you have on an existing RO system, and that's where you're going to see the benefit. COD limit is kind of hard to give because it depends. It's going to be different for everybody in different industries. I was talking about landfill leachate. Esmil here talked about COD that's extremely high, tens of thousands. It all just sort of depends on. It's going to be different for every industry, I guess, is a way of answering that.
Okay. And do Esmil provide all the pre-treatment processes before the RO step? If so, are these systems designed and manufactured in-house?
Yeah, I can answer that question. Yes, Esmil provide all the pre-treatment process before the RO step. And for those particular case studies, we had a drum screen on the UF system, and they're all designed and manufactured in-house.
Okay, fantastic. And then I think there's another one here for you. So do Esmil have experience working with high pressure RO up to 120 bar?
I can answer that as well. Yes, we supplied one system where the RO is ultra high pressure RO system, which operates up to 120 bar. And application where the emulsified oily feed was to be treated. So we had ultrafiltration followed by RO to get that high pressure application system to achieve that requirement. And we also supplied a system for acetic acid recovery where the pressure could go up to 83 bar.
Great. Okay. Does the feed water need to be softened?
Yeah, you're still going to have the same issues with scalants with our RO membranes that you would have with a conventional RO membrane. So, carbonates, sulfates, those are all going to be the same. You still need to do projections to figure out what those will look like. It's really the organic issue, the organic valence where we stand out. So that's why we talked about MBR effluent, where you're going to have COD, passage into the RO membrane. That's really where you're still going to need to handle the scalants, though, the way you would handle it with a normal RO membrane.
Okay. And then we've got, how do the high pressure BWRO membranes compare to seawater RO in regards to permeability?
Yeah, so they're going to be more permeable than a seawater RO. Seawater ROs usually has different conditions with the way they're tested. I will say, just in general, though, if you're comparing, these membranes to other membranes, what you see on a spec sheet isn't necessarily going to show you what you're going to see in the field, especially if you have a complex waste stream or you have organics. The actual normalized flow that you're going to see with our membranes is typically higher than that of a similar brackish water membrane. But comparing seawater to brackish water is a little different, just based on the membrane chemistry itself. It's going to be a tighter membrane if you're talking about seawater.
Fantastic. Okay, do you have experience rejecting fats, oils, and grease from water used in processing beef?
So I'll answer that one. We've done a lot of extensive pilot work and work in the meat and poultry industries. So we do have experience with concentrating the organics and fats, oils, and greases in beef processing, for example. And I would love to talk to you about that separately. If you have a specific project in mind, you can reach out to one of us and we could talk about that after.
Brilliant. And then there's one related to that. What is the max fats, oils, and grease that membranes can handle?
So I'll answer that one as well. So it depends on the product, but for superfiltration, one of the defining characteristics that we've noticed in superfiltration when we were first commercializing it is that we have handled streams with up to 50,000 ppm of fats, oils, and greases. It really is dependent on the type of wastewater and where it's coming from, but we don't have a max fat, oil, and grease limit on the superfiltration membrane. And for RO, we've seen, it also depends where it's coming from, but we've seen our RO operate in streams that have a few ppm of residual oil and grease.
Fantastic. Okay, have we got any experience in treating oil and gas produced water with values of 180,000 ppm TSD with oils and fats?
Yeah, I can take that. Yes. We actually did a study with the U.S. Department of Energy treating produced water in the Permian Basin. And so very high TDS in that area, around those levels that you mentioned, 180,000 ppm. That was using the superfiltration membrane. So like Brendan mentioned, the superfiltration doesn't reject dissolved salts. So it'll operate at low pressure, even on high TDS streams, but it'll still reject all of your fog, your oil and grease. So it's a really good pre-treatment for downstream processes that helps get rid of any remaining fog that you have in your produced water.
Can I say something on this produced water treatment?
Yep.
Yeah, so Esmil has supplied a system for the produced water treatment. This is for a project in Ireland. The end user was a shale oil. This is 18,000 ppm TDS that's coming from the formation water breakthrough. So we supplied a system which has got a UF, nanofiltration and polishing, activated carbon filter, and an ion exchange unit to make sure water quality is suitable to take it back to the sea. So Esmil has done this project.
Brilliant. Okay. And then someone's asked if the slides can be shared. So yeah, we'll be sharing the recording with all registrants in a couple of days following the webinar. And then the next one is, do you have a comparison tool to find easily the appropriate alternative type of membrane versus DuPont, Hydronautics, LG, or other?
So yeah, I can answer this one. As of right now, we have an internal projection software for RO. So if you are able to send us over your water quality and your desired outputs, we can do internal projections for you and share that.
Fantastic. And then another one here. Is there a temperature limit? Have you applied to produced water?
Yeah. Oh, you want to go ahead, Brendan?
No, you can go.
Okay. Yeah, temperature limit for superfiltration is 50 degrees C for our newest generation of superfiltration membranes. The RO membranes right now are 40 degrees C temperature limit. So like I said, superfiltration probably a better fit for the produced water. Kind of depends on the amount of TDS you have, the recovery rate you're trying to get, but we can work with you on that if you have a project that you're interested in.
Brilliant. And then how do ZwitterCo membranes handle salts and scaling?
Yeah, so same thing I said earlier, you still, for RO membranes, you still need to have anti-scalant or pH adjustment. You're still gonna have the same issues with scaling, but the real advantage is with organics.
Okay. And then one for Esmil here. Why did Esmil choose ZwitterCo over other anti-fouling membranes?
Uh, yeah, so anti-fouling membrane, I mean, it has got a certain limit over the organics and the other foulants. And ZwitterCo, we found it can handle a lot higher organics, very high COD. And then before we decided, we did some quick lab testing using the 4040 modules, and we found that it's working well. There were no drop in the performance. The statistics was very good. So that was the reason we decided to go with ZwitterCo.
Brilliant, thank you. I think that's all we've got time for. We're just about running out of time now, so I'll pass it back to you, Brendan.
Okay, thank you, everyone for attending the webinar and having some questions for us. We hope you found that it informative, and we truly hope that you enjoyed the webinar and you will consider using our membrane technology products in your food and beverage applications and your wastewater streams. If you have any further questions, please don't hesitate to reach out to any of us. Our emails are listed on the screen, and we can also share after.